Hi everyone and welcome to my YouTube channel. So we're continuing our inequalities playlist, and in this video finally we'll be wrapping up AMGM. Of course in the next videos we'll be dealing with other super important inequalities, but today we'll be simply finishing the final ideas of the AMGM. So what are we waiting for? Let's get started. So our first example for today is the following. So we're given that A, B, C, D, their product is 1, and the four numbers are positive, and we're asked to prove the following inequality. So basically it's just sigma A to the 4 times B. We need to show that it's greater than or equal to sigma A. Of course the sigma is cyclic. Okay, so how exactly can we deal with such a question? First of all, this question is really neat, as we don't have any fraction or anything like that, so it should be the perfect question for the AMGM. But first of all, we have a condition. How can we deal with this condition? This is question 1. So if you remember, in our previous lesson we discussed a very important idea, which was the homogenization idea. So how can we get rid of conditions? By simply homogenizing the inequality. So let's take a look at our inequality right here. So is it homogeneous? What is the degree of the left hand side? Simple, the degree is 5. All the terms have degree 5. On the other hand, the RHS, all the terms have degree 1. So it's not homogeneous. How can we homogenize it? Let's think using the condition. It's super easy. This gives you degree 4, this gives you degree 0. So we simply actually multiply the right hand side by A, B, C, D, and we're done. That's it. So our inequality actually is equivalent to proving sigma A to the 4B is greater than or equal to sigma A square B, C, D. So this is actually our inequality. Now we can totally forget about our condition. Now we have simply 4 numbers, 4 positive numbers, and we are asked to prove this inequality. Okay, so how can we solve this question? Right now, you should already have a clear goal how we can proceed with this question. So the plan is pretty simple, just like all the problems we were doing, the classical problems, like sigma A square is greater than sigma AB, or any such problem that is just some polynomials. We don't have fractions. We can just use the pairing technique. So this will be our goal here. So let's apply the pairing technique. So how can we do that? The idea is simple. We want to get A square B, C, D somehow from the combination of these numbers. Of course, that requires us to write the four terms in order for us to know what we should pick. So let's just write them. A to the 4B. We also have then B to the 4C, and also C to the 4D, and we also need D to the 4A. We just need to combine these somehow to get A square BCD. So let's think, how can we do that? Well, we need to get A square and B and C and D. So we need basically all of course the numbers here. But A should have more, like kind of more weights than B and C and D. And the only way to do that is using this A to the 4. So of course we'll be needing to use at least one of these. Okay, so if you use one of these, then we have used a B. We also need to use a C and D as well. So we need other stuff as well. So actually we need C and D to be the same weight as B. So that requires us, maybe you might say, let's use this. But if you use this, okay, now you have 4 C's. So now actually like these are not enough, so we also need to use these. And then if we do that, then we will actually need to use b to the 4, because now okay, we have too many c's and d's but not too many b's. So as you can see, this is a mess, and we need to use all of the numbers, and it's not even clear how many times we should use them. It's not like the previous simple pairing techniques that we were using, in which we can immediately guess how many we use of these. Most of the times it was, for example, super easy, like just use two of them and we get this. Or just like the other problems that we did, where we used 2 of these, one, and 1 of these. Here, no, the thing is more complicated. Okay, so at times like this, what can we do? The main problem is we're 100% sure that the pairing technique will kill this question. However, we're not knowing what to use. How many of this, and this. So, what's the idea? Don't worry, the idea is really simple. We'll just be doing this by force. So instead of guessing, we'll just force the equation. We will force some numbers x, y, and z, and t, and see some equation, write some equations, and solve them. So this is basically the idea. Okay, so let's imagine we have picked like x of this, y of this, z of this, and t of this. And let's simply imagine that, yes, we were done. What equations we will have? So if you thought about it, if we have x of these, and y of these, z and t, then when we apply the AMGM inequality, here, of course, how many of these? Of course, the number here is x plus y plus z plus t, but we really don't care about this number right now here, because whatever it is, when we add them up, it will cancel. Our main issue is the powers. What will we have here as powers? So we will have a to what power? Let's think about it. What is the power of a? Well, since here we have x of these, so we will have 4x. And where does a come from? From here. So we'll have plus t. The same thing for b. It's for y plus let's see, plus x, and then c for z plus y, it should be, and finally d, it's for t plus z. Okay, but of course that's not enough, because we have a big root over all of them. And the degree of this root is pretty simple. It's just x plus y plus z plus t. So what does this mean? That means we just have here sigma x divided by all of these. Like 4x plus t, sorry, divided by the sigma x. Okay, so let's translate this into real equations. Let's see, what does that mean? So that means that what we want actually is the following. Of course, we don't care about the LHS, we care about the RHS. We want to make the RHS the same as this. So we simply just be working on the powers. So imagine what do we need in order to get this as a square b c d? Simple. We need this when we divide like 4x plus t over sigma x, we want it to be 2, and 4y plus x over sigma x, we want it to be 1, and the same thing for the others. So let's simply write these equations and proceed with that. So the equations are the following. 4x plus t is equal to 2 times sigma x. Same thing for the others, but without 2. And then 4z plus y sigma x, and 4t plus z is also sigma x. Okay, so now we have 4 equations and 4 variables, right? Well, actually no. If you think about it, one of these is fake. One of these equation comes from the other 3. I will leave this to you to figure out why, but it is actually pretty easy to see why. So instead of working with the 4 equations, since one of them is fake, so why should we use the 4 equations? Let's just use 3 of them. The main idea is if you can find an example, then you can multiply all the numbers by k. It will still work. Like it will still satisfy that. So actually one of the equations here is really fake. By the way, remember that our goal is not to find all x, y, z, t. Our goal is not here. Our goal is to solve this question, right? So if we can just figure out some value for x, y, z, t, then that will be enough. Anyway, let's now pick up these three equations because, like, okay, the symmetry here, like here, if we pick this one, it has a 2. Let's just pick these and see like what each one of them gives us. So this one gives us what? Okay, let's cancel. 3y, the x cancelled, so z plus t. Here 3z is equal to x plus t, and here 3t is equal to x plus y. Alright, we have these simple three equations. Let's see how we will work with them. Well, one technique I'm thinking of is, for example, if you find x from here is 3t minus y, then we substitute it here, and then we go from that. Okay, so from here, we know that x is 3t minus y. So that means if I just substitute here, I know that 3z is equal to 4t minus y. So now I can simply find y. Y is 4t minus 3z. And hence now I'll just go substitute here everything. So I'll substitute y, and I will substitute also. Okay, let's just substitute y for now. So we'll get 3 times 4 is 12t minus 9z is equal to z plus t, and hence 11t is equal to 10z. Alright, so we got this. 11t is 10z. And of course we can express x and y in terms of these as well. Okay, so remember our goal is not to find all x, y, z, t. It's enough just to find some example. So we can from this actually kind of guess what we can do. It's very simple. Let's pick z as 1. If we oh sorry not as 1, I mean here, if we want to make these equal, then the simplest example we can provide is z as 11 and t as 10. So 11 and t as 10. Now it will solve this issue here, this equation. Now let's figure out what is y. So y is 4t, 4 times t, so it's 4t, minus 3 times z, so 33, and hence it's 7. Alright, so y is 7. Okay, what about x? Well, x is 3 times t, so 30 minus 7, so that is 23. Alright, perfect. That's it. We found our like x, y, z, t, and hence we can apply AMGM and we'll be done. Imagine like that we can guess these. It will be super difficult, right? Kind of impossible to guess these. That's why here we use the idea of forcing the equations and simply solving them to get what we want. Alright, so basically now how will you write the solution? You will just say, like you're some magician, and you just simply say by AMGM we can write what was it? Sigma a to the 4b, yes. So we start with a to the 4b, a to the 4b plus 7 b to the 4c plus 11 c to the 4 d plus 10 d to the 4 d to the 4, and now a. And now by AMGM simply we will get that this is greater than or equal to Okay, if we add these numbers, 21, then 28, and 23. I think it's 51. Yes, 51. 51 and a square b c d. That's it. This is by simply AMGM, and we simply take the sigma of all of them and it will cancel. And so basically we're done. Okay, I will not write the whole solution because from here, by just summing and cancelling, we will get our inequality. Okay, so as you can see, if you just like look at the solution and see this, you will say, wait a minute, how did they think of this? However, the only thing that we simply did is just forcing these equations and we were done. Okay, so that means that the pairing technique, like if you ever get stuck in the pairing technique, then just use this method. All right, so that finishes our first example. Let's move on to the second example. Okay, so in this question, fortunately, we don't have any condition. We just have three positive numbers, and we just need to show the following: x plus 2y plus 5z is greater than or equal to 12. We have square root, we have xyz, and we have x plus y plus z. Alright, how can we solve this question? Well, first of all, okay, we have something here, x plus 2y plus 5z, 12, and here we have some kind of root over xyz over the sigma x. So if we actually, first of all, just take this one there to see what is actually the LHS and RHS, it's simply the following: root sigma x, let's say, and times x plus 2y plus 5z is greater than or equal to 12 times root xyz. All right. Right now, if you just look at this inequality, you should be kind of comfortable. Why? Because remember, from our experience with the AMGM, we've seen so far that xyz is always very small. And guess what? Here, we just have something like sigma x and some stuff. We need to show it's greater than xyz. So that means this is very good for us, because AMGM for sure will kill this question. So one idea, okay, to simply go and apply AMGM. So if we apply AMGM here, we know what we're going to get, like 3 cubic root xyz, and then we'll have like a root here, and now it will be a 6th root here. Now we want to apply the AMGM. Now here the problem starts appearing. If we want to apply AMGM here, we will get stuck. Why? Because if you want to apply just like this x plus 2y plus 5z, like here you have two possibilities. Either you will just make this one number and this one number and this one number. Okay, now you will get indeed xyz, but your main issue is that you will get something like this: 3 cubic root of, okay, xyz, but times what numbers? Times 10. And now of course you are going to see that you are not getting 12, unfortunately, because clearly these don't give you 12, like cubic root of 10 and 3 and another square root of 3. So this will not actually work. Alright, so this is bad idea. Maybe then you will say, okay, let me pick this one number, and 2y, let me make it y and y, and then z plus z plus z, and so on. However, this is also a bad idea, because guess what? Now you will not even get xyz. You will get x, y square, z to the 5. So this is very bad. So neither of these work. So unfortunately, it seems that our application for the AMGM is not as easy as it looks. So what exactly are we going to do? And why are we failing with the AMGM here? Well, here comes the really important idea I was warning you about in the beginning of the lesson 1. That is the equality case of the AMGM. Like when you want to apply AMGM, you always need to keep the equality case in your mind. Because let's see, when we are applying the AMGM on this number, and this number, then the equality case holds when x equals 2y equals 5z. And we wanted to apply the AMGM on x and y, z, z, then the equality holds when x equals y equals z. Well, do any of these work? Like, does any one of these gives us really the equality case in the question? So, for example, if you go ahead here and set x equals y equals z, will the equality case hold here? Let's, for example, see x cubed over 3x. So this will be x squared over 3. So it will be x over root 3. For sure, if you put here all the numbers are x, it will be just like 8x. So as you can see, it's not, the equality case is not holding. So when x equals y equals z, this is not the equality case. And of course, we can feel that from the, not like here we don't have any symmetry. This is not symmetric, like x, 2y, 5z. Usually, all of our previous problems were kind of symmetric because x and y and z, they had the same coefficients. Okay, so x equals y equals z is not the equality case. Well, is this the equality case? Well, you can easily see that no, actually, it's not, by simply plugging them in, plugging them here. So the first thing we need to do is to figure out when does the equality case happens. So I want you to think about it and then continue with the video. So the equality case here actually holds when x and y and z are 1, 2, 3, or 3 to 1, I think. Because now if 1, 2, 3, then this is 6, and this is also 6, so this whole thing is 1, and now the right hand side is just 12. Okay, this is super nice. Now if 3 to 1, then 3 plus 2 times 2, that's 4, plus 5, so this is indeed a 12. Okay, so that's great. So now we figured out what is the equality case. Now, if we want the equality, if we know that the equality case holds when x, y, z is equal to 3, 2, 1, we need now to make this guide us in our application for the AMGM. We will not just apply random AMGM because they will fail. So what we'll be doing is simple. To help us understand or kind of think in a nice way, because our mind will always try to apply AMGM when x equals y equals z. So let's force our mind to be comfortable, kind of. This is actually a funny thing. But we will be really using the idea of forcing. This is really, really important through your Math Olympiad journey. So the very simple method is to do the following. Let's make x, define 3 variables, x prime, y prime, z prime. So we'll just make x as 3x prime, y as 2y prime, and let's leave z as z prime. Now, we will write the new inequality in terms of x prime, y prime, z prime. But guess what? Now, indeed, the equality case will hold when all of them are equal. Right? Because here, the equality case does not always hold, not just only for 3 to 1, but actually 3, let's say 3t, 2t, and 1t. So we will just be doing this trick. Now, we will force the inequality to have equality case when all the numbers are equal. Oh, anyway, let's now write basically the new inequality in terms of that. So first of all, x prime is now 3x prime. Actually, let's write it from here. It will be much simpler. So we have root. Actually, let's even like square it. It would be even more beautiful. So if we square it, we will have 3x prime plus 2y prime plus z prime. The other thing is actually squared, but it is anyway 3x prime plus 4y prime plus 5z prime squared, and we need to show that this is greater than 12 squared, that is 144, times, okay, now we have 6x, y, z, all primes. Okay, so now we simply need to prove this inequality. But the cool thing is that now the equality case holds indeed when all of the numbers are equal. So now our goal is to apply AMGM here and apply AMGM here, indeed, in order to get this. Now it's super easy because, okay, now we can just use the standard AMGM. So now let's just make this as x prime plus x prime plus x prime, y prime plus y prime, and z prime. So we can easily write that this thing actually, using the AMGM, is greater than or equal to, okay, how many variables? There are 6 now. So 6 and of course 6th root. Now it's x cubed, y squared, and a single z prime. The same thing we'll do for the others. If we apply this, how many we have? 3, 4, and 5 is 12. 12 and x cubed, y to the 4, z to the 5. Now we square this. We just square this both sides. And of course you just multiply them, and indeed you will be done. In fact, you can see easily that 144 will appear from here times 6. And of course I will leave the rest to you to check that indeed if you multiply these, then you will get x prime, y prime, z prime. Alright, so that was a really important example on the equality case. You really need to focus on the equality case, especially to guide you apply the AMGM in a correct manner. We also solved another problem, if you remember, I think in lesson 2. And that example also showed us the power of knowing how to apply the equality case in order to guide us to apply AMGM correctly. Okay, so now let's finish our lesson finally with the final example. So we have now 3 numbers a, b, c. They are positive, and we need to prove. Actually, I forgot where was this taken from. What Olympiad? If you know, tell me in the comments. Okay, of course, as always, I will not write it all. I will just write sigma and 1 a, b, c. Okay, so we just need to show that sigma 1 over a cube plus b cube plus abc is less than or equal to 1 over abc. So how can we do that? Alright, take your time and try to think about this problem. As you can see here, our problem is not just like sigma is greater than a sigma or something, like they are polynomial or because we have fractions here, of course. So how can we exactly deal with such a problem here? Well, maybe someone will think of expanding everything. This is actually a common idea, that if you multiply everything by pi this thing, like pi a cube plus b cube plus abc. Okay, now you will get rid of all the fractions, and then you will have sigma like stuff greater than sigma stuff, and all these are polynomial form. Actually, this is really a common idea, but the problem is it's super ugly, super like time consuming, and also like you might make errors here and there in the calculations. Actually, we will be discussing this question or not this question, this idea, I mean this technique, the expanding technique, in our next lesson when we learn Muirhead's inequality, because then it will be really cool, although we are going to suffer a lot in the expanding process. However, the Muirhead will really make our application for the AMGM much easier. Now imagine like you have tons of sigmas, and then you have also tons of sigmas on the right hand side, and then you need to figure out what's the AMGM that is going to kill these. It will be a really difficult task, because like maybe you will take some of these here, some of these here, and some of the terms here to combine them to kill one of these. So it will be kind of really difficult. However, when you take the Muirhead, you will see that this will be kind of much easier. Anyway, right now this is not our goal. We will not expand. We need to find a kind of clever application for the AMGM to help us tackle this question. Well, the idea is the following. So look at the LHS. Of course, we can't do anything on the numerator, and we need to show that it's less than. So we can work on the denominator. But if we want to work on the denominator do we want to increase it or like maximize it or minimize it, kind of? Do we want to make it it's less than or equal to something or greater than or equal to something? Well, the answer is this. Why? Because if you want to increase the fraction, then you need to increase the numerator and decrease the denominator. This is a rule of thumb. So we want to decrease this. So basically we need to apply some AMGM inequality that do the following. This is greater than or equal to something. Then we can just apply going from LHS to RHS. So okay, what can we use? This thing, how can we minimize it? ABC is already minimized, so we should work on the A cube plus B cube. Well, we have multiple techniques here. We can apply the AMGM here, so something like this. But this will be like really difficult and ugly and not cool at all. We want most of the times to make stuff much better, not worse. So what can we do instead? Well, one idea is this thing is actually a plus b times a square minus ab plus b square. So we can't do like kind of anything cool here. But here, look at it. A square plus b square is already greater than 2ab. So 1ab will cancel. So we'll have this is greater than or equal to a plus b times ab. Hence, we can just replace it with a square b plus b square a. Alright, perfect. So a cube plus b cube is greater than a square b plus b square a. So let's see, does this help us? So now that means that the LHS is less than or equal to sigma 1 over a square b plus b square a plus abc. Okay, what is this? As you can see from the denominator, you can take a common factor. So let's do that. This is actually sigma. Okay, what can we take as a common factor? A and b, and then we'll have a plus b plus c. Alright, that's super nice, because now we can even take this as a common factor, right? Because now like you simply have a plus b plus c in all of the terms. So let's do that as well. So if we take this as a common factor outside, now it's just like this. Alright, perfect. Now let's return to our question. What do we need to show? This is less than 1 over ABC. Let's take the ABC there. If we take the ABC here, multiply this by ABC, then clearly this will be super nice, because this will be what? It will be just AB, for example, here will cancel. We'll just have C. So actually, now ABC times the LHS is less than or equal to, okay, let's leave this 1 over sigma a, but now we indeed have here sigma a, because ABC times this is C. Then we'll have C plus B plus A, so it will be sigma a. So guess what? Sigma a times 1 over sigma a is just 1, and hence we're done. That means that the LHS is indeed less than 1 over ABC, and we are done. So as you can see, this application of AMGM here, I call it internal application of AMGM, because we're applying AMGM not externally but internally on this specific part, not like something like the previous questions. It was not just that we are applying AMGM on the whole thing, the whole of that. Here no, we just pick something, some part of it, and we just apply the AMGM, kind of an internal application. So you should always keep in mind this idea. Of course, always when you want to work with fractions, you should know here you can maximize the numerator or maximizing the numerator, yes, and minimizing the denominator. So we just did that, and indeed we were done because of this application of the AMGM. Super simple application, but once you do it, it immediately tackles the problem. All right, my friends, so that's it for today. All right, so as a summary, we have seen so many applications of the AMGM during our kind of 4 lessons, and now of course we'll be moving to other inequalities. In the next one, we'll be working with the Muirhead inequality. So as you have seen, we have many ideas for the AMGM. I'm going to repeat the ideas like super fast. the most important ideas we applied. So we have seen that the AMGM inequality is really a powerful one. Of course, one condition you need to be careful is that all the numbers should be positive. You need to always check that. We've seen many techniques that we can do the AMGM on. For example, we can actually find the maximum or minimum of some expression that only has, for example, x, a single variable. But you need to always be careful. Use these ideas. Like you imagine you're applying the AMGM. How can we make the AMGM good? Because it's not always immediate direct application of AMGM. Another idea we discussed is the pairing technique. The pairing technique was one of the most powerful tools in the AMGM, and in this lesson we also learned how to apply it in force when we can't just guess what to apply. We also saw that sometimes it's okay to apply AMGM in reverse. So instead of going from the big hand side to the lower hand side, small hand side, then we can go from the opposite. Also, we saw one idea, that is homogenization. This was probably the most important idea you need to keep in your mind, because it helped us solve many hard problems by simply getting rid of the condition. We actually did one of the problems here today, the a to the 4b sigma 1. And we also saw the importance of the equality case, which was illustrated by the previous example that we solved together, second example in this lesson. Finally, we saw one application of internal AMGM. AMGM is not always just applied externally. Sometimes you just go apply AMGM on a specific quantity in your inequality, and this will simply solve your question. Alright, my friends, so that's it for our AMGM. And as I told you, in the next lesson we'll be just discussing a new inequality, that is the Muir-Hitz inequality, which is just a kind of a special case of the AMGM, but we will see what's the importance of it. Okay, my friends, I hope you have enjoyed this video. Please like, share, and subscribe to my channel, and see you guys in the next video.